So let us discuss. Now this is a circuit in second case. We have kept second source, which is my 10 volt source, and remove the first one of 20 volts. Okay. So my 20 volts is connected over here. I have removed it. If you notice, I placed a wire. It's because since it's a voltage source, I have shorted it. Now with this circuit, my job is now to find the current in the 7 ohms with this source present in my circuit. So once you get the circuit, again give the flow of directions with respect to my second source. So if you notice, when the second source is present, the current is going to flow from right to left from my 7 ohms, and with this junction it is going to split up into two halves. One is going to flow from top to down, the second one is going to flow from left to right. Okay. Next is, I have to find my current in my 7 ohms resistor. So if I have a look, the current in my 7 ohms resistor is actually the current from my voltage source. So it is actually the total current coming from my battery. So for my total current, I can use this Ohm's law to calculate. So if I use Ohm's law, the formula for current in 7 ohms would be V by R. In this case, V is 10 volts. R I will write it as R equivalent. Now while writing R equivalent, I have to consider two things: is which resistors to put, and second is how to write the equation. Okay, two things that you have to consider. Now, R equivalent is the total resistance being offered by the circuit to this 7 ohms resistor. That is the meaning of this R equivalent. So if I have a look at the circuit over right now, the current in my 7 ohms at this node, say I call it as node A, will split itself up into two parts. One part will flow through 5 ohms, second part will flow through 2 ohms. At this junction it will end up and go back to my source. So what's actually going to happen is, the current in my 7 ohms is going to indirectly flow through 5 and 2 ohms. Okay. So while writing the equation for R equivalent, I have to consider 5 and 2 also along with 7. That is, my first part is getting cleared. I have to consider 5 and 2 along with 7. Now how to write the equation? Your source is over here, so say you're standing over here. Your circuit is lying to your left in this case, to my left. So start from the last end of where my circuit lies. So when I write that R equivalent, it will come out to be, when I start from my left hand side, first I will come across with 5 and then with 2, and both of them would be parallel. 5 and 2 both would be in parallel. That would be series with 7. So that answer what I get, say let me call it as A. Put that A over here in R equivalent. Whatever is the answer that I get, I call it as B. So the current of 7 ohms that is flowing in that circuit has a value P. Now this is the magnitude of it. I need to also give it a sign. Now how to give a sign to it? To give signs, compare this direction in my 7 ohms with the original circuit. If both directions are matching, the answer will be plus. If both the directions are not matching, the answer will be minus. So if I compare this direction right now with this directions, they are mismatching. So it is minus P. Okay. So what I can understand is the current in my 7 ohms resistor with only 10 volts is minus P. So if I connect an ammeter over here, the magnitude of current would be the same as value of B, but the direction is not the same as what you have assumed. Okay. Now, what we have done up till now, if you have a look, is first of all we have found out the current in 7 ohms only with 20 volts. That we have got it as plus Z. Now have calculated the value in 7 ohms, considering only 10 volts, we have got the answer as minus B. How do you get the final value of current in 7 ohms? That is, what you have to do. You have got the current due to 20 volt source in my 7 ohm resistor plus Z. You got the current in 7 ohm source, 7 ohms resistor, because of 10 volt source as minus B. Okay. These are the currents in 7 ohms when both sources are acting individually. Your job was to find the current in the 7 ohms resistor when both the sources are acting simultaneously. So how do you get that answer is, whatever values you have got over here, that is in this case, plus Z, which is because of 20 volts, minus B because of 10 volts, you have to algebraically add, meaning plus Z you put and minus B. Okay. Now, the final answer will be plus or minus C. Meaning, for example, let me give you the value, say Z to be as 5, B to be as 1. So the answer for C will be 4 and it will be plus. So what is happening over here? If Z is greater than B, then the Z value is dominating for C and the sign will be plus, as in this case. So what you come to know is, whatever the magnitude of 4 amperes is flowing in 7 ohms when both the sources are acting simultaneously and the sign is plus, so whatever direction you have assumed over here is correct. The second case can be, okay, this is case 1, case 2, Z can be minus 5, Z can be plus 5, okay, B can be 7, greater. So the resultant would be minus 2. So in this case it would mean that the current flowing in a 7 ohms resistor is 2, but since the sign is minus, it means that whatever you have assumed over here is not right and the direction has to be changed. So the direction will change if the sign over here is minus. Okay. So that will depend upon who is greater, if Z is greater or if B is greater. So these are the two possible conditions. Sign will only reflect on the direction of current. So this would be your final direction of current. So what would happen is, if I connect an ammeter over here, connect both the sources and match the value of current, that value of current should match with these values. So what I am actually doing is, in this circuit by using superposition theorem, when you are given more than one source present in the circuit and you want to find the current in that particular resistor, the procedure going about it is, you find the current in that resistor, which each energy source acting alone, get the magnitude of currents, and finally do the algebraic sum of the individual source currents that you are getting. An answer that you get will give you, okay, the final value of current flowing in that same resistor when all the sources are acting simultaneously. So now, in case of there are two sources over here, there are more sources. What are the changes? There's nothing to worry. Only over here your final answer would be plus Z minus B. Whatever is the next term, say plus or minus D, and it will go on increasing depending upon the number of sources. So this is what is going to happen. So now I expect you all to do is, in this values, whatever, substitute the values, simplify and get the answer. So this is your superposition theorem, and it's a very important theorem to